we have been doing so far all sorts of image processing, image analysis step, but we were doing them manually. It means we were clicking on menus, which is of course fine if we are processing one image or few images, but it becomes impractical if we had a lot of images, hundreds images to process or even more. Luckily, one of the nice features of FIJI is that it allows you to automate your workflow in quite an easy way. So for those of you who have some experience with programming in whatever language, this will be very easy. For those of you who are new to programming, this might be quite an easy way how to learn to program and automate things. So there's a tool called macros in FIJI, and they allow you to run an automated processing sequence of processing steps. And why I say it is easy to start with macros is because there is a macro recorder. If you go here on the plugins, so here under macros, there's record macro. So if I select this option, then there will appear a window, a recorder, which will record the commands which correspond to whatever I do now manually in image chain. So let us try some processing steps. I will open an image. For example, I will open this image which is one of the sample images in FIJI. I have just inverted the lookup table, and let's do some steps. What we tasks we have done. So, for example, we go to process, filters. We run a median filter to smooth the image. Then we can apply a lookup table, image, lookup table, and we can apply some funny lookup table like this one, for example, and then we can change it to RGB image. Let's say we want to have an RGB image with this lookup table, which we want to then use for our presentation, for example. So then so I have done a few simple steps, which are nothing difficult if I have only a few images to process. But imagine you had hundreds of images, then it would be painful enough. And you can see what we have here recorded. So we have opened this image. We have done filtering with median filter. I have applied a lookup table, and I have changed the image to RGB color. Now, if I want to run this on all images in a folder, I can go to here, process, batch, macro, and you see I have here these commands which I have done. I have here some commands recorded here. It's not exactly, so I can copy. I won't copy the opening of the files because that would open every time the same file. I'll just open the processing step which I have applied on the file. And then I can select input, which is desktop, FIJI test, select, and then I can select output, so I can save the processed images. Here on the FIJI test, I have created a folder called results. And then I can run process. Close this one first and run process. And we can then check the results. And you can see we had 3 images, 3 copies of the same image in the original, in the input folder, and now we have 3 processed images in the output folder. So this is was quite simple, and but we can of course do much more complicated. We can include many more processing steps and do a much more complicated automated pipeline. Now there are of course limitations of what can be done in this way by simply recording the processing steps. So sometimes we need to do some adjustments to the code in order to get more possibilities. So let's now go to a little bit more advanced thing. We will still use the recorder, so I will clean the recorder. We will still use the recorded sequence of steps, but then we can do some changes to it. And we will then create a new macro, and we will copy the commands. We will copy them here, and we can save the macro and then run it in the future. You can see that we can say file save as to save later our macro. We can save it to desktop, and we can call it macro 1.ijm. IJM is the extension for ImageJ macros. The macros can, you see, you can in this code editor, you can use different languages to write your code. I am using now ImageJ macro language. ImageJ macro language is based on Java. So if you know Java language, then you know ImageJ macro language. The only difference from generic Java language is that you can use specific commands for ImageJ, which commands to do various image processing steps. So let's first hide this, and let's do some processing steps. So we will open again one of these block images, and let's say that what we want to do this time, something similar what we did when we were looking at segmentation. So let's say we want to segment objects in this image, and then we want to measure the average intensity in the segmented objects. So I don't want to have the average intensity of the whole image. I just want to have the average intensity inside of the objects of interest. So that's why I need to do the segmentation first, and then I will have the image which only contains the segmented features. The rest I will, the background I will make to infinity so that it doesn't affect the average. So let's do what steps the process. Again, we do filtering, we do median filter. Then we go to image, adjust threshold, and we can choose which algorithm we want to use. In this case, Otsu algorithm looks quite okay, I would say. And so I will apply. And maybe I forgot to do one thing. So I will still need the original image, not the binary. So I will do image duplicate. And then I will, so what to delete this, not to confuse us. And on one of the images, I will run the thresholding, image adjust threshold, y, and then I will do divided by process math divide by 255, and next I do process image calculator, and I will divide the original one with the mask. And here I have the segmented image. So then what I do, I will analyze, measure. And I have the result here. So then we have this code here. And we'll copy it to our new macro. And now we want to do some editing. So one thing, these steps they are commented out. So if you want to, if you write these two slashes in front of a line of command, that means that it's a comment. So this is something which will not be interpreted and executed. So you can write different. In this case, it commented out these two lines of commands because they are irrelevant. And you can also notice that each line in the code ends with a semicolon. This is important. If you forget the semicolon, it will be cause confusion, so things won't work. Now you can see one problem. If we want to automate and apply this macro on other images, then we have problem, because here we are specifically referring to certain image files. So once we open a different file, this code won't work, because it wants to work with image which is called blobs.tif and blobs-1.tif. So one way how we can make it more generic is, instead of using the particular names of the images, we can use give our own references to the images. So one way how we can refer to images is by so-called image IDs. And because each open image is recognized by FIJI by a unique ID, a unique number. So when we have first we have the image we want to process is the active image, and then we can use command, and we will call this is the original image or input image, so we will call it input equals to get image ID. So now if I refer to the image as input, I will be referring to the original image which was active in the beginning when I started the macro. So then I run median filter, I duplicate the image, and now I need to have a reference for my duplicated image, which is the one that I will on which I will do the binary thresholding. So I will call it mask get image ID. This is now still the active image. So some zooming, which is not needed. So I will do the command set threshold and convert to mask. And divide that image by 255. And then I run image calculator, where I want to divide the image called input by the image called mask. And it will create a new image. So I will call this image output. Now, I believe after this, I generate this output, it should be the active image. So I don't need to call it, but let's say, so I can run measure, but then if I want to close the original image and the mask, so I can call select image, and this is argument, which is the ID of the image. So I select input, and then I do command close, which will close the image. And select image. So you can also notice that when I am typing some command, I can see some reference, some help to that command. So this is useful. Select image, mask, and close. So now we have our macro. I will now close the images. And I will open again so we can test the macro if it still works. So I open the original image, and now what I do is run. Okay, here the last line I made a typo. So you see there is a close. So now we can try to run it again if it works. And we open the image. And it works. So so now we could, of course, use the same tool for batch processing to run it, and then we will get the results here for all of the images. But let's. I'm not a big fan of the batch processing tool, so I usually, if I run, well, we can try that just for image process batch. And we can use the same input and output, and we can run process. Now we get you see we get the results from all three images. But there are situations where this batch processing tool is not may not be suitable or may not be so convenient. So let's do, because especially one thing which one limitation here is that it does exactly the same runs the same code on every image in the folder. But sometimes you might want to do something more than that. You might want to do some processing on all the images, and then, for example, generate a single output from all of the processing results, or from all the analysis results. So in that case, we have to use other tools available in macro language. And one thing, like in any other programming language, we can run loops. That means we can certain portion of the code we can run in many iterations. So we can create a loop which will work on all images in a selected folder. And for this, we first need to use a command to select a folder. That will be the input folder. So we will use the command get directory. Here you have the help to it, and it's a command which will generate a dialog where the user selects a directory. And this string here, this is a message which will be shown as the name of the window. So we can call it, for example, we can write a string select input. Then, so now we know where the input is, and now we need a list of all files in the input directory. So we will first name this input directory, and then we will generate a list get where is the get file list directory. So here we give the name of the directory, which we called there. Here, so get file list. So now we have the list, and now we will create a loop which will go through the whole list and open each image. So for this, we will we first need to know how many iterations we need to know. So we will call this, for example, n will be the number of files in the folder. List length. So this is a command which will give me the length of the list. And then we do a loop. So we will do a for loop, which is a loop with a fixed number of iterations. So we will go. So we will start with index equal to 0, and the index will be increased by 1. This is a command which increases the index by 1, and we will go until as long as the index is smaller than this n is the number of the files in the folder. And then what we do is so we want to open, but we don't want to open any type of file. We just want to open an image. So we want to make sure that we are opening an image. So we can say that if, and this is another type of features in any programming language, that you can make if clauses. So you can define a condition, and then a portion of code will be executed only if the condition is met. So in this case, we ends with. So that means so the string in this case will be the item in the list. The item and this case is the ith item on the list, and we want to end with you're asking if it ends with TIFF. Now, but we expect there to be TIFF images. So only then we will execute the rest of the code. And now we need to open the image. So we open, and the path to that image is the directory plus list. Right. So now we have the image open, and then we copy here the rest of the commands. So now it should run the same processing steps on every image in the directory. So we can try to run this macro. Run. Now we are asked for, we want to select FIJI test. Okay, and yes. So we you see there's one bracket was missing here. So now let's try again. And you see, it worked. So now we have here all the result images. And next, what we might want to do is that we want to save these segmented images. We want to keep them for reference. Let's say we want to check whether the segmentation did work and find if, let's say, we see then that for some image we are getting weird values, that the average intensity is out of the range, so we can check maybe there was something wrong with the segmentation. So we want to save the images. So for that, we'll we can save it by adding a command here, save as, and we define the format as TIFF. And now we need to give it the path. So we want to save it to the subfolder, which the results subfolder. So the path would be there plus, and then the name of our subfolder, results. And then we want to add the name of the file. So for that, let's call it name, and we can read the name here when we open the file. So we say the name get title. So that will read the name of the file. This is the same as the title of the open image. But now, if this is not yet correct, so if you remember, when you give a path to a file, there always has to be a backslash between the directory name and the file name. So if I would put here backslash, you can notice that now it looks weird. And the reason is that backslash is somehow changes the meaning of the quotation marks and so on. So we cannot use that. So what we have to use is plus something which is called file file separator, and that will add the correct sign for the file separator between the directory name and the file name. So we can do it even in a better way. So we can create the subfolder in case the subfolder doesn't exist, so it doesn't give us an error, but we will create it. So we can copy this path. We can create a, so we can say that results directory is give the path, and then we say file make directory results directory, and then here instead of giving the full path we can just say results directory. So to test that if it really works, I will delete the results directory and I'll run the macro. Need to go here, FIJI test. Let's see if it's, and yes, it's here. So if I open it, there are 3 images, and I can check that they are really the images which they are supposed to be. And yes, it's the segmented image. And here I have the results table. I will close these images, and now that I have these images saved, so I might not might be messy if they stay open. So I can also close the segmented image, and you have noticed also that when the macro is running, it opening all the images. So it's doing basically, it looks like as if we were doing all the steps manually. And that actually slows down the execution of the macro. So we can improve that here we say set batch mode. The argument in this case is true. So we will run now, the macro will run in batch mode. And if I run it, so it says it's finished. So it was finished quite fast. It's hard to notice now whether it's finished or not because I don't see the images appearing. So to see the progress as the macro is running, I might want to add a progress bar. So that's a command show progress. The current index is I, and the final index that is N. So now if I run it, so you could see that there was very briefly, there appeared a progress bar as the macro was running. Next, what we can do is you see we have here the results, and as we repeatedly run the macro, the results are accumulating. So it's becoming a bit messy, because then we don't know what belongs to what. There might be even results from some other macro or from other measurements we have run manually. So it's good that before we run the measurements, we'll clear the results. So before we do the before we run the macro, so in the beginning we say command run clear results. So we can now try it. So I have now the 3 results. Now if I run it again, let's see, and still only the 3 results. So it cleared the results from the previous run of the macro. What else can we improve? So now we have the results, and we might want to save them. So you can do File, Save As, and you can save it as a CSV table. But one thing, you don't know to which file this result belongs. So it would be useful to have the file name there as well. So for that, we can generate our customized result table, which will show exactly what we want it to show. So I'll close this, and now instead of run measure, we will use a command get statistics. So it gives similar statistics as the command run measure, gives area, gives mean, minimum, maximum, standard deviation. So now we just need to put these values to the results table. So we say set result, and column will be the name of the column. So the first time it runs, we will define the names of the columns. So one name of the column could be name. So that will be the file name. And value is name. Then next, copy this. Then we say mean, and we put the mean, which is what interests us the most. Then we can take the standard deviation, and the last thing we can take the area. Let's try. Okay. Sorry. Here I was copying, but I wasn't changing the names. Now run. And here we go. We have the file name, the mean intensity in the segmented object, standard deviation, area. So that works. Now we can save this, but we can also make the macro save the results table automatically. How we do it? So we save as, and in this case the format will be results, and we want to save it again to the results directory. The class, and we'll call it result, for example. So we can check whether it saves it. Run test, and we'll see in the. And yes, there is. But now we should give it also the extension so that it knows what file type it is supposed to be. So let's say results dot CSV, comma separated values. So now it's working. I think it's working, doing what we wanted to do, but maybe let's try something to add some other feature to it. So one thing, let's add their user input, interactive user input. So sometimes it might be useful that the macro can stop and wait for user to do something and then continue. There are situations when the user input is needed. For example, there might be cases where it's difficult to automatically segment the right features. So that it might be segmenting features which don't belong there. And it's by thresholding, we can't distinguish what belongs there. It needs the input from the user who knows what the features of interest should be. Of course, in principle, yes, it can be automated. We can, for example, train a neuronal network to recognize what are the features of interest, but let's be realistic. So let's say we need the input from the user. So there's a command that we can tell the macro to wait for user. So let's do it at this stage. So we want, when we segment it, so before we do the measurement, before we do get statistics, we want to we want the user to be able to delete some of the features which don't belong there. Let's first move this up, because here after this we already don't need those images, the input and mask. So now we just need to select image, output. We do the saving later because we want to save it after the user deleted what doesn't belong there. And now, before we do the get statistics, so now we need to exit the batch mode so that the user can see the image. So this is a command if you want to exit the batch mode. For example, if your macro generates output image which you want to be visible when the macro ends, so you can add there a command set batch mode exit and display. Now what we do is wait for user, and title can be string input, and message, we tell the user what to do. We say delete wrongly segmented objects, if any, because there might not be any wrongly segmented objects. And then we return to the batch mode set batch mode to and now, so when we use this command wait for user, the macro will stop and user can do whatever they want. They can open images, they can draw regions of interest, delete parts of images, basically anything. So we do run FIJI test. So now we are asked, so maybe we are happy with this, so we press OK. Now in this image, we'll delete, for example, this feature. OK, and here we delete most of the image. OK, and we'll see the results. And now you see the results look pretty weird. So one thing, why do we have here 0 as the mean? Well, the reason is because we selected a region of interest, and now when we use the command get statistic, it gets the statistics only on the region of interest. So we need to unselect the region of interest. So we need to do what is the command? Run select none. Okay, this is so run select none, and we can try it again. Okay, here we delete one object, and here we delete a larger part. And let's see the results. And now you see one disturbing thing, that the mean is actually changing. And the reason why it's decreasing as I am deleting more and more of the image is that it's when I delete it, then the pixel values are set to 0 instead of the infinity or not a number, which is what would exclude those pixels from calculating the mean. So this is obviously not perfect, and we'll have to do something about it. In a while, I'll show you how this can be solved. But let's do something before. I'll show you some more tricks that can be useful. So one thing here is that we have here the radius which we use for the median filter, and it's set to 2. But of course we can change it in the code. I can put here 5, 1, whatever. But when I have a longer macro code, it might be inconvenient if I want to change some parameter to look through the whole code and find all the places where I need to change. So it's useful to define the parameter in here somewhere in the beginning to be visible. So I can say this is filter diameter, for example, I call it, and now I set it to 2, and I can give a comment to it that this is the what is it's not they call it, it's the radius or the it's radius. So filter radius is 2. So we say this is the radius for medium. And now instead of having here 2, what I'll do is I say radius, and now to connect the string I say here plus filter. It's offering me already filter. Another thing, because now we have here that we are waiting for user to do the selection, and sometimes we may not need it. In some cases, let's say we don't expect there to be any problems with the segmentation, which would require user input. And the user input would be just inconvenient because the user need to click every time OK. So we can put here again an option, user input, and set this as a Boolean variable, so it's either true or false. Let's say allow user modification of some description, we know what it is, and then we'll do this command that we wait for user. Or the whole thing we can do the set batch mode. We can say that we do it only if that thing is true. So we can say if clause, if what was it, user input now user input is equal to true, but in this case it's just enough to say if user input. If I want to say condition if user input is false, then I would use an exclamation mark. So now it means if user input is false. So if user input is true, wait for user. Let's now solve some other thing. So we had here this issue with the mask. So we had that if I delete, I will have the zeros. So one way how I can solve it is I need to change whatever I deleted, the selection I need to change to infinity or to not a number value, so that it doesn't change the average. And one easy trick to do would be to divide the selection with 0. So I can copy here this command, and here I have the user made the selection, and before I delete the selection, I will do divide by 0. That will because dividing by 0 doesn't make sense. So if I divide 0 by 0, it will give me something which is called not a number. Let's try. So The first one I leave as it is, then I delete something, and now I delete something else, and I do OK. And now you see here in the first case, the mean is not a number. Why? Because I had no selection, so I divided the whole image by 0. So I have to make an if clause here. Make sure that only if a selection exists, I divide it by 0. So if selection type, and selection type returns, if I go back here, selection type, you see that it returns -1 if there is no selection. So selection type, it the other way around. If it is -1, I don't want to do the division. So run, select this as it is. And now you see that the mean value doesn't change too much. Only the area changes because I deleted some of the segmented objects. And I can also check the folder, and you see I have the results here, and there is this results CSV folder which contains the result table. There's one more thing about macros which is worth mentioning, and so you can always open the macro. So if I save the macro, I can open this macro file. It will open in this code editor, and then I can run the macro, or I can use Ctrl+R shortcut to run the active macro. But if there's a macro which I use every time, I can make it easier so that I don't need to open the macro every time. And there's something called macros, startup macros. And this is you see, it's a macro code which contains different macros. And I can add my macro to the startup macros code. So I call this macro one, whatever, and I will enclose this code, and then I could copy everything and I can pass it here. So this should be as a text name. I can also define a keyboard shortcut which will run the macro, but I have to check which shortcuts are free. So shortcut so he's sorry. Here's a list of all shortcuts. So I can find a letter which is not used. For example, letter Q is not used. So I can say that macro 1 will be started by shortcut Q. And then if I won't be working immediately. So if I now press Q, it doesn't do anything. I would have to restart FIJI, and then it will Q works. And here we go. Let's generate one more simple macro where I will show you some other things that can be done and which might be useful. So we create a new one and want it to be image macro, file, save as, and call it macro 2. And now what we want to do is that we want to generate images with if you saw the part where I explained Fourier transform, so I had those images with periodic bright and dark stripes. So I generated these images by a simple macro, so we can create such a macro. Again, we can use the recorder for some simple to help us to get started. So first we need to generate a new image. New image, we can generate a black image where there's nothing there. And now, of course, in this case, we know what is the size of the image. But let's say I just want to show you a very useful command, which is get dimensions. So this is a useful command if you open an image which can have different size, different number of channels. So this is a command which will help you to read these values. In general, you might have noticed that there are a lot of commands which start with the word get, and those are commands which help you to get some value, either name of the image, or here in this case the dimensions, or if you specify, there's also a command get, for example, get pixel, which will give you the value of a pixel which has the coordinates x and y. And then there are commands which start with set, and we will use now one command where we assign specific value to each pixel. So we will be using command set pixel, where we give the coordinates and the value. But so now what we want to do is to assign values to each pixel, which will be periodically changing from high to low to get this sinusoidal pattern. So we will run a loop across over all the pixels in the image. So we again do for loop, and in this case we will, let's call this x, because it's the x coordinate of the pixel, and it's smaller than the width of the image. And another, and because we have to run also do it for every row, So then we do a loop over another loop over the other coordinate y, as long as it's smaller than height of the image, and y will be increasing it by 1. And then we'll do here, we will set the pixel. But we need to give it the value, and the value will be changing with x. It doesn't change with y. So we can calculate the value here before we do the inner loop, and the value will be it's a sine, we want it to be sinusoid, changing sinusoidally, so it will be sine of the value x, and we want to define a period in pixels. So we will do times 2 times pi divided by the desired period. Now I didn't give here, I don't give here a number. I could specify a number, the period, but I can do it in the beginning. For example, 20. Now I can say this is the period of the sinusoid in pixels. Why I do it in this way? I mean, in the line which is 10 lines of in the case of a code which is 10 lines, it doesn't make too much difference. I can easily find the place where I set the period. But if I have a longer code, it might be inconvenient if I want to change the parameters to look through the whole code to find every place where I need to change it. So it's useful to define these parameters in the beginning, and then I just call it by the number, by the name of the variable. So we can try to run. But of course, one thing which I should do, because sinusoid is changing between 0 and 1, so it won't give, so I would have to adjust the contrast, so it might be better if I do it plus 100 times sine. Now I can check the period. You see, it's, if you look here, the width of the, it's rough, it's 20 pixels. So that's what I can also look at the profile. So you see that here 20 pixels is the period. So that's correct. If I want to make things fancy, so that users don't need to change the code, I can also let users define the period. So I can do dialog at number. I will call it period, and the default value would be 20, for example, and then period is dialog get number. And I have to make the dialog show and dialog create, and we call it settings. So now we run it and we change it to 50, and we have a sinusoid with a larger period. Another way approach here is that we can define functions, and we can call it sine wave, and it will be given the parameter which is coordinate, let's call it x, and then we say that value equals to, and it will do exactly this calculation and return value. And then instead of calculating here the value, we will say that we want to sine wave x. It works. So this is, again, in the case of such a simple code, it seems redundant, but it might be useful if you have some block of code which needs to be done repeatedly. So it might be useful to define it as a function, and then you can call it from different places in the macro. And so I think this is all I wanted to show you from the topic of macros. If you have any questions, ask.
Okay, so these are the images. You can see that some of the particles move over time, and a few of them actually split and merge into either more particles or into one more particles. As you can see, the particles here also disappear at certain frame. Like here, it disappears and it merge later on. So using, for example, TrackMate under tracking here, you can load the TrackMate plugin using the default parameters here because it's in pixel, so it's 1 pixel. You can then select a detector. Let's use the default detector. The detector is to detect the blocks in the image. Here you can specify the estimated block diameter. So if the block is smaller or bigger, you can actually give it a number. So here maybe I estimate it to be about 5 to 6. So let's make it 6. You can choose preview, but as you can see, there's a lot of detected particles. This is because the threshold now is 0. As you can see, there's a lot of background, small little spots at the back. So you can actually increase the background, let's say to 10, and then you press a preview again. Then you can see that it actually picks up, now it picks up the particles. But over here, you can see that it doesn't really pick up. It should be 2, but it's picking up it as 1. So maybe my block needs to be smaller. So when I make the diameter smaller, you can see the threshold probably needs to be a bit higher. Otherwise, it detects the other stuff. So, yep, I think now it managed to detect this as 2, but it also detects this. So maybe I go a bit higher as well.
Maybe if I can add to this,
yep.
It doesn't really matter if it detects more particles, because there's another step where you
yep.
can do thresholding of the particles.
Yep.
That's in general, it's more robust than setting the threshold in the detector. So the authors of TrackMate, they recommend rather to have more particles, rather to use lower threshold, even if to use 0, and then to do the selection in the subsequent step.
Yeah, okay. So once we are okay with it, we can also use a median filter to remove the noise. But let's go ahead with this selection. Here you will have the histogram of all the located spots. Let's just proceed. And here you can actually filter the spots. So for example, you can filter like the quality of the detected spot. You can filter also, for example, by X if you want, like the coordinates. But here, let's just not filter anything and just take all the data. And the best next, you will try to do a series of algorithms to track the spots. I'm not so familiar with the rest, but usually I use the simple tracker. Beyond this step is what you specify the linking distance. So for example, so this is the distance that specify how much each spot move across a particular frame. So if you put it too low, it will not be able to track. But I think the default 15 pixels should actually do it. The closing frame here, let me put 0 so that you can understand when I press next. So this is to actually include particles that actually disappears during the track. For example, this guy, right? It disappears. If I put 0, then what will happen is it will then track this as individual spots, right? Because I don't actually try to link it. So if I actually put 2, this will say that within 2 frames, if it disappears and the next frame actually comes back within 15 pixels here, it will treat this as one single track. So if I do this again, you can see it's one single track, right? So these are some of the basic options. And beyond here, it's again filtering. You can filter tracks with number of spots, number of gaps, etc. Yeah, I think after here is basically just for display, the different stuff that you want to display. You can press on the analysis button here. This will show you, for example, some of the basic stuff like how much it being displayed. I think there's a velocity. Yeah, you can actually calculate the speed of the track, etc. Yeah, I think the rest are not so useful. It's more statistics. You can of course then export all these right out. Finally, of course, you can actually plot some of the charts here, but I usually don't do that. I usually go all the way to the end and export it out as a I think there's a I think I can export it out as a XML file, or I thought there was a CSV file, but I might be wrong somewhere. So I can export it and open up in Excel for me to do things. That's my understanding of this plugin. Of course, I skip quite a lot of stuff. You can actually add or remove spots using the track scheme. So you can actually manually link spots if you think that the tracking actually fails or there is some error along the way. Right, I think that's all for this. If Vedek wants to add anything, you can go ahead.
Thank you, Yongli. Maybe I'll add a little bit to this. So the plugin TrackMate, as you saw it, it's to find the trajectories. It doesn't do analysis of the trajectories. There are other plugins, for example, trajectory classifier, which is then can take the trajectories and perform some analysis on them, or you can do it, of course, in other software, or there are other plugins which do the tracking as well as some analysis of the trajectories, such as finding the mean square displacement. There's one which is particle tracker 2D 3D. It does similar things as TrackMate and does also the analysis of the trajectories. Only I found that TrackMate has a bit more options in terms of how to do the detection and tracking of the particles. So that, I think, is more advanced in TrackMate. But I might be wrong, because in the past I've used TrackMate. I haven't really used this one, so I just checked it, and maybe it's just my unfamiliarity with it. These plugins are mainly for tracking of small particles, so something which looks like the particles in the example which Yongli was showing. So that means some small blobs of intensity. There are other tools for tracking specifically different objects. So, for example, in the web page I mentioned last time, Bioimage Informatics Index, if you search for tracking, you will find different tools. So there are also some tools which are for FIJI. So, for example, there are some very specific tools like microtubule end tracking in Drosophila oocytes. So, or there's also TrackMate, of course. Or, for example, what else is there in FIJI? Some other tools developed by other groups. So you can, and of course, as I mentioned, this is definitely not a complete database of all image analysis tools. There are other tools which you might find in literature for tracking some specific types of objects.